My name is Audra Benchovel, and I'm a marketing engineer in the C.D.S group at Trane. Today I will be talking about unmet hours, what they are, common causes, and possible solutions. By the end of this video, you will be able to define what is an unmet load hour and how they are calculated in TRACE, know how to identify the hours within the project, and understand common causes of unmet load hours and steps to take to eliminate them. First, what is an unmet load hour? Per ASHRAE 90.1, an unmet load hour is an hour in which one or more zones is outside of the thermostat set point range. The total unmet hours of a building are the summation of the number of hours when the heating or cooling set point temperature of a zone is not met by either the HVAC system or plant. Unmet load hours can occur for a wide variety of reasons and are triggered in TRACE when there is an excess load on the coil that is at least 1% greater than the design coil capacity, and at least one room attached to that coil is plus or minus 1.5 degrees of the thermostat set point for that hour. Now, why is it important to eliminate unmet load hours from the building model? Well, to comply with ASHRAE Standard 90.1 Appendix G Performance Rating Method, the total unmet load hours for both the proposed and baseline models cannot exceed 300, meaning that the combined total of unmet cooling and heating hours must be below 300. In the 2007 standard, the unmet load hours in the proposed model cannot exceed the baseline building by more than 50 hours. This is important specifically when modeling for LEED because this requirement must be met. Unmet load hours occur if the room's thermostat set points are not being met within an acceptable margin in a 1-hour time step, which can be a sign of thermal comfort issues in the building. It may mean that the building is not being controlled well or reflect improper operation of the equipment. Further exploration as to the cause of unmet load hours will need to be done in order to resolve them. One thing to note is that reducing unmet hours can result in an increase in energy consumption, as the equipment may have to run more to provide more heating or cooling to meet thermostat set points. Let's step through the process of identifying issues and resolving unmet load hours. The first step is to identify the unmet load hours. How many unmet cooling and heating hours are there? What rooms and systems have unmet hours? What time during the day are they occurring? These are just a few of the questions we need to answer to understand the underlying cause of the loss of space control, rather than just arbitrarily adjusting inputs to reduce or eliminate the unmet hours. To help identify unmet hours, there are two reports that can be used. The first is the Energy Cost Budget Report, which will give the cumulative number of unmet cooling and heating hours per alternative. This report will give a good high-level overview regarding any potential problem areas. In this example, we can see that we have a total of 3,746 unmet heating hours that need to be addressed. The second report is the Building Temperature Profile Report. This report allows you to view more granular information about unmet load hours and has a detailed accounting of unmet cooling and heating hours associated with each room per system. In this example, we can see that all the rooms are triggering unmet hours. If we page through this report, we will see an unmet hours section that provides more information about months that the unmet hours are occurring in each room. Looking at the unmet hours portion of the report, it will tell us in what months, time of day, and day types that the unmet hours are occurring. By seeing when they occur and thinking about what is happening in that room during that time, we can begin to get an idea of the possible issue. Note that the unmet hours in the Building Temperature Profile Report are not additive. Any space can trigger an unmet hour, but if multiple spaces have unmet conditions during the same hours, then only a single unmet hour is tallied. This means that an alternative can have a maximum of 8,760 unmet hours. Once the problem areas have been identified, a good place to start is to review the data entered. The following are suggestions that, based on support calls, are common places where errors are made. This step targets commonly overlooked assumptions in the TRACE data entry process, as well as the complex interactions that typically occur in building simulations. This is meant to only bring attention and does not necessarily require action to ensure the model is set up as intended. Each building model is unique, and the impact of each of these steps may be different. Only solutions that apply to your project should be applied. To start, let's utilize the Scan for Errors feature prior to calculating to help identify any potential errors and inconsistencies. These are just warnings from Trace and do not necessarily require action. It will report many but not all of the issues to be discussed that need attention and can help solve simple causes of unmet load hours, such as mismatched schedules or thermostat set points that are too high or too low during occupied or unoccupied times. Perhaps the single largest area of uncertainty in a building simulation occurs when scheduling internal loads. Trace allows different design and simulation internal load schedules for proper coil sizing. If the design schedules are too moderate or overly conservative, coils could be undersized and not able to handle dynamic building changes that are not accounted for during design calculation. For more information about creating and using schedules properly, see our Trace 700 utilization schedules video. Proper thermal zoning of spaces and properly modeling thermostat location is vital to proper building simulation. Ensure that spaces have been properly zoned per design documents and have been entered correctly in the Assign Rooms to Systems section. For more information about proper thermal zoning, please view our video on Assign Rooms to Systems. When a space is unoccupied and there is no thermostat schedule applied, the space is allowed to use the drift temperatures. If there is a wide variance between the occupied set point and the drift point, the HVAC equipment may not be able to handle the pull-up or pull-down loads in the 1 hour time increment as the building becomes occupied, because the equipment is sized per the thermostat set points and assumes steady state conditions. Verify the temperatures entered are accurate representation of the actual building thermostat controls. The same suggestion applies when utilizing thermostat schedules. However, realize thermostat schedules are not affected by occupancy, but rather follow the user-defined schedule exactly. Trace has fan control options allowing the program to intelligently cycle the fan to meet changing load conditions. Avoid scheduling fans manually because the simulation may not match up with the expected fan operation schedule. Leaving the fan schedule set to available 100% and applying a fan cycling schedule provides the most accurate method for controlling the fan operation. The same can be said for the Coils tab, where each of the coils schedule is best left as available 100%. Scheduling a fan or coil as something other than available 100% can quickly lead to a high number of unmet hours. Trace design coil capacities are determined at steady state conditions, assuming the space is always controlled to the desired design space set point. In some instances, pull-up or pull-down loads associated with dynamic building operation can exceed the capacity of a coil. These dynamic conditions are not accounted for in the design process. A common example of this is night setback thermostat controls that allow the building to drift during unoccupied hours. As occupancy increases in the building during the early hours, the design coil capacity may not be large enough to condition the spaces to the desired set point in a single hour, triggering unmet hours. Applying the optimum start control strategy allows the building automation system to condition the spaces in advance to reach the desired set point when the building becomes occupied. It is recommended to set the schedule to available 100%. Hopefully, the preceding strategies have helped reduce or solve the unmet load hours issue. If not, here are some additional non-typical solutions to investigate. Users often want to schedule ventilation to follow the occupancy schedule. This concept is valid, but incorrectly modeling this causes problems. The standard occupancy schedules in Trace do not work well for ventilation. Since ASHRAE recommends not taking credit for internal heat gains, standard occupancy schedules set the heating design schedule values to 0%. When used as a ventilation schedule, the 0% value for heating design exempts ventilation from the heating design calculations. The result is undersized heating coils that cannot properly heat the space when the ventilation air is introduced during weekday, Saturday, and Sunday calculations. Instead, a more conservative approach would be to utilize the standard ventilation schedule. The only difference between a standard ventilation schedule and a standard occupancy schedule is the heating design value is set to 100% for ventilation. Another potential reason for the unmet load hours is when applying a dedicated outdoor air unit on the system. It's important to note that if the supply air temperature is something other than room neutral, it may cause conflict with the system or spaces it will be serving, and unmet hours may result. The outside ambient conditions are what determine if the DOA unit is in cooling or heating mode, which may differ from the mode of the system. For example, based on the outside air, if the DOA unit is in cooling, it will introduce the ventilation air at the specified cooling supply air temperature of the unit. But if the system is in heating, that ventilation air may put an additional load on the system that Trane did not account for during design. This conflict most commonly occurs when a cooling and heating supply air temperature for the DOA unit are not the same. For more information about setting up a DOA unit, see our video on modeling dedicated outdoor air systems. In VAV systems, the heating airflow is limited by the minimum stop of the VAV box, which results in not enough airflow reaching the space to satisfy the load and manifests as unmet heating hours. Review the zone checksums report to see if the heating supply temperature appears unusually high, and if so, consider increasing the VAV minimum for the space. Likewise, if the space does not receive the required ventilation during the heating due to the minimum stop, select Actions, change load parameters on the menu bar, and check the box for forced VAV min always greater than or equal to nominal ventilation during design. This will adjust the VAV minimum automatically to ensure the space receives the defined amount of ventilation. Much like with fan schedules, applying a schedule other than available 100% to the coils can quickly lead to a high number of unmet load hours. If Trane needs a coil to satisfy a load and the coil is scheduled off, then the load will not be satisfied and will carry over to the next hour. Likewise, undersizing coils or turning coils off can lead to unmet hours. It is best to leave these schedules set to available 100%. Most buildings contain rooms like closets that are not conditioned directly by a mechanical system. If these types of rooms have been included in the model, it's important to define them as unconditioned. An unconditioned space will not receive any cooling or heating from the system to which it is assigned, and light and miscellaneous loads are still calculated, but space temperature is allowed to drift. Unconditioned spaces are not factored into the unmet load hour calculation, however, may impact a conditioned space if the ceiling or underfloor plenum is shared with a conditioned space, or if the conditioned and unconditioned space are connected by an adjacent airflow partition or exposed floor. Another option to consider is increasing the system coil capacities to help reduce the unmet load hours. This should be carefully considered as it will impact the overall size of your system. The system coil capacities can be increased in Create Systems on the Coils tab. These coil capacities are automatically carried over to the plants that they are assigned to, thus increasing the plant size. The coil size can either be increased by a % design capacity or can have an actual capacity unit specified. If you do not want to adjust the capacities by increasing the coil size, the other option is by specifying a plant capacity and selecting the Link Airside Coil Capacities box on the Change Energy Parameter screen. Changing the equipment capacities in the plant section alone has no impact on the system simulation unless you have checked this box, which allows Trane to take the specified plant capacity and back calculate the size of the system coils based on what capacity is available at the plant level. Note, only one of these options should be used to increase capacity. If the system coil capacities are adjusted, the plant linking feature should not be utilized because it would override whatever is specified for the system coils. That is all the information I have for you today about unmet load hours. Hopefully this helped answer your questions and solved any issues you might be having with them. Here is a list of additional resources that we have available for more information about some of the topics discussed in today's video. Thank you for taking the time to watch. Please feel free to contact C.D.S. support either by phone or email with any follow-up questions, and have a great day.